this is what the agenda. We are going to learn what is microservices, why we need microservices, what is monolithic architecture, then what are the drawback of this monolithic architecture, then why microservice came to the picture. That's what the advantages of use microservices. So let's understand now the first one, what is microservices. So before explain what is microservices, I want to convince one thing guys here. So the first thing is microservices is not any kind of technology. It is just an architectural way to design our application to maintain loosely coupled from one module to another module. Okay, so let's understand it. Microservices architectural way to design our application uniquely with several small modules where we can develop, packaged and deployed our application individually, and the entire process is the individual process. So there is no tightly coupled between multiple modules. That's what the advantages of microservices. So we'll understand in more depth about the microservices once I will cover all the slide with architecture. So now let's understand why we need microservices. Before microservices, industry what they are using, like what problem they faced before microservices. Okay. So why microservices came into picture, where previously we are developing and deploying our application in efficient way in monolithic approach. So it means before microservices, industry was following the monolithic approach. So what exactly this monolithic approach? Let's understand it. So now let's understand what is monolithic architecture and what was the problem there in monolithic architecture, so that people are going forward to use microservice. So this is what the architecture of monolithic. Okay, so in monolithic approach, what we are doing normally, we are developing our every service individually, and at end of developing, we are packaging all service as a single WAR file, and then at end we are deploying it in server. Okay, so that's what I mentioned in this architecture. So if you observe here, passenger management is one service, billing, notification, each are one service here, and we are developing each service individually. Then at end, all the service we are packaging in a single WAR, then we are deploying it to the server. So here you should think what is the problem in this monolithic architecture, where as usual we are developing a service and at end we are packaging them as a single WAR. Okay, so it looks good. Now let's come to the point, what are the disadvantages of this approach. The first disadvantage is performance issue due to huge data. So now let's understand what exactly this performance issue in our monolithic architecture. Let me show you the diagram. Okay, so as I told, after development all we are deploying as a single WAR, right? So the performance becomes slow because huge data present in that WAR, and once the application itself become big, so quick development and delivery become too much difficult, isn't it? If I will do here passenger management, billing, notification and all the services, if I will bind to a single WAR, then all the modules, class, object, what we did in the code will be part of the single WAR, and that WAR size will be more huge. So that's what the performance issue. While deploying and while developing also, it's not giving us the good performance. Now move to the next disadvantages. The next disadvantage is continuous deployment not possible. So what was the problem in continuous deployment? So let's understand it. So assume as it is the monolithic architecture, we need to deploy single WAR by binding all the services. Assume there is some bug or defect in passenger management, and I open that passenger management code and I did the changes. Okay, so as it is monolithic, I can deploy this passenger management as a single WAR in my server. Again, I need to repackage all the services, even though there is no issue in billing, notification, tree management, driver management, only issue is in passenger management. I did the code fix, but again I need to repackage all the services. So that's what the continuous deployment issue in our monolithic architecture. Even though we are going to change in a single service or single line, then again you need to redeploy your entire code base. Okay, come to the next point. Adopting new technology will be difficult. Okay, so let's understand what will be the cause or what will be the problem if I will going to add a new technology in between one module. Okay, so here assume I have a passenger management, billing, notification. Suppose all the services I used Java code. Okay, in notification service I want to use some Python or some other technology, but ultimately at end we are going to package all as a var and we are going to deploy in a server. So if I will change the technology of a specific module, it won't allow me to, or we can say it's not kind of compatible with other module, right? So this is what the one kind of biggest problem in our monolithic architecture. Technology we can't choose. For all the services we need to choose same kind of technology. If you are developing all in Java, then all we need to do is Java code only. Suppose notification or payment, a single module I can't change with any other technology. Come to the next point. Overload ID and overload web container is similar to our performance issue. As I told, everything we are packaging in a single var, so there the container will also able to take the load of that var, so there is no more productivity in this case. Okay, so the next one is exception propagation not proper. So what exactly this exception propagation is not proper in monolithic architecture? Suppose assume in my driver management I am getting some exceptions, and so in that case it will impact on all the services, because driver management internally use the notification for email notification or message notification, or it directly connect to the payment through REST call. So one service is getting failed here, then it will impact on other services. So there is no proper exception propagation management kind of thing in monolithic architecture. Then move to the next point. Code readable is not there. So what exactly this code readable, guys? Like assume one new resource join in our project and he got some tasks. So how he can analyze? To analyze it, first he need to understand complete flow to know the exact business of a specific module. Okay, so let me show you that. Suppose one new developer join in my team and there is some issue in payment services or billing services. I assign a task to that guy, that user I assign to work on billing services. But to understand what exactly this billing service is doing, so he need to go through the entire code base. He need to understand what this passenger management is doing, what driver management, trip management. So he need to understand entire flow. Then only he can identify the root cause where exactly he need to do the changes. Okay, so these are what the problem we faced in monolithic architecture. So let's revise once again. The first one is performance issue due to huge data. As everything we are packaging in a single var, so the data will be more or huge in the var. Continuous deployment not possible. So if you are going to change in a single module, again you need to redeploy your entire code base. Adopting new technology will be difficult. So we can't change the technology specific to a single module. So in all the modules we need to be, it's not support for interoperable. Okay, so the fourth one, overloaded ID and overloaded web container, as I told, it's same as a huge data in a single var. So exception propagation is not proper. If one module is getting failed, then it will impact on other module, whoever communicating with that module. And the code readable is not there. So to work on a specific module, first we need to understand the workflow of entire module. So these are the issue we found in monolithic architecture. So to overcome those issue, microservice architecture came into picture. Now let's understand using microservices how we can resolve those issues. Okay, so move to the next slide. So this is what the microservice architecture. So if you can observe here, passenger management, driver management and trip management, each are different service and have their own database, different database. For trip management I am using trip database. For driver management I am using driver management database. For passenger management I am using passenger management data. So this is what the typical microservice architecture. Now let's compare the disadvantages of monolithic architecture and then how we resolved in this microservice architecture. So in monolithic, the first one is performance issue due to huge data. as everything we are packaging in a single var. So in case of microservices, each have their own dependent, like passenger management have their own deployment, driver management have their own deployment, means the development of each module will be independent and deployment also independent. Like we no need to combine all these three modules as a single var. I can develop passenger management and I can deploy it as a single var. Similarly for driver management also, for trip management also, each module we can deploy it as a single var instead of combining them in a single var. So the first one, performance issue due to huge data. Assume I done with the development for passenger management and I am going to deploy that particular passenger management microservice. So in that case, only the code or the classes or the library what are there in passenger management I am going to deploy it as a single var. So the load for that particular passenger management var will not be more. The data is not huge. Similarly, same for driver management. So there is no performance issue, like as we are deploying each microservice as a individual var. So the next problem was in monolithic. There is a problem in continuous deployment. So if you come to the microservices, suppose there is a bug or defect in driver management, then directly I need to go to this driver management code base and I will check, I will analyze what is the root cause and I can fix it. And then instead of redeploy all the module as a single package, I can only redeploy the driver management. I no need to touch the code of passenger management or trip management. So the continuous deployment will be more easy in case of microservices. So there is no dependent for driver management with other microservices. Wherever you are doing the change, you can deploy or we can package particular that module. Okay, so this is how the continuous deployment will be more easy in case of microservices. And the third one is adapting technology. Okay, so as each are their different module and deployed as a single var, suppose I want to develop this driver management as in Python. So I can write the code in Python, I can connect the way Python is connecting to the database, I can do the same way. And at end I can, like if I want to communicate with passenger management from driver management, I can do the REST call to that particular passenger management or trip management. Like that we can adopt technology whenever you want. Like as I told, microservice can contain multiple modules. So wherever you found suitable technology which can give you the better performance, we can easily change that. And the next problem was in monolithic, that is the exception propagation. So if you come to the microservice architecture, suppose my trip management service is getting failed and from driver management I am invoking the trip management, then that time I can add one additional layer, or we can say in microservices they provided one component that is the named historics. Using historics, that's kind of circuit breaker design pattern, or we can say fault tolerance tool. Okay, so using historics that we can propagate to the other services. So that is what the advantages of microarchitecture to handle the or to propagate the exception. The last drawback is in monolithic architecture is the code readable is very difficult in monolithic, where in case of microservices, assume one new resource join in our team and I assign task him to work on a trip management. Then he can, as I told, each business we have creating a different module, so he can directly come to the trip management and he can fix the defect and he can redeploy it. So that's what will be more easy. He no need to go through the entire code, what driver management is doing, what passenger management is doing. So he got a task in this particular module, he can go to that, he can debug and he can easily fix it. So that's what the code readable is more easy in case of microservice architecture. So what are the drawback we discussed in monolithic architecture that we can easily resolve in microservice? That's what I explained in this current slide, right? So let's go through a typical microservice architecture once again. So this is what the typical microservice architecture. So this is the client. Client will send a request and it will goes to the API gateway. So API gateway for this microservice architecture If you are going to the Java, Spring Boot provided one API gateway, that is the Joule API gateway, who will help us to redirect the URL. Suppose URL is coming for passenger management, it will redirect to the passenger management. Based on incoming URL which we configured on this API gateway, based on that URL, it will propagate the request to the corresponding microservice. So once request will come to the passenger management, so if passenger management talk to the payment, he can do the REST call. Similarly, you can see all the what microservices is individually developed here, and whoever want to communicate with each other, they are invoking with REST API call. You can observe trip management, billing, similarly driver management, notification, they are communicating via REST API call. And for passenger management, he have their own independent database. For billing, he have billing database. Like this, for specific to a module, all the required software, all the required dependency will be separate for a particular module. Okay, and if I did the code change in a specific module, I can only need to redeploy that particular module. Suppose in payments, I need to deploy on that payment only. I no need to bother about the billing, as already billing, passenger, driver, all the module up and running. Okay, so this is what the typical architecture of microservice. So this is the comparison between monolithic architecture and microservice architecture. As we discussed, in monolithic architecture, request will be come from UI, then business logic. In business logic, we have all the module. All the module data will be bind to a specific var, and even they are using the common database for all the modules. This is what the monolithic architecture, and there was lot of problem which we discussed already, and that's what we overcome using the microservice architecture. So request will come to the each microservices, and each microservices have their own database instance. Okay, so this is all about microservice and its architecture. Now you might have question how we can achieve this microservice architecture, means which technology we need to use. So as far I know, Spring Boot provide complete support for this microservice architecture. That's why Spring Boot provide few component like Hystrix, Eureka Service Registry, API Gateway, Joule, all those things provided by Spring Boot. Okay, and even I uploaded all the component video in my YouTube channel. Let me show you that.